This is the CS2420 class, and we're going to continue on with our B-tree class, and we're going to code this insert method. So I've already got my function all set up. I called it item up there. I'm just going to be consistent even though it doesn't matter. I've got my template class type, my void insert, my open and closing brackets. I do need my scope resolution operator. There we go. So this is my function, and I want to insert an item into a binary tree. Now the way this works is we need to first find where it goes, and if we look at starting at the root, we can check the root, and if that's null, then we know that that's where we want to put our pointer. So we're going to say if root equals null pointer. That means we have an empty list, and whatever we add to the tree becomes the root. Root equals a new node, and then I'm going to set the item of the root equal to the item that we were just sent. And then I have to set the children to null because this means we only have one item in our tree, and that's the root. So I'm going to set the left child equal to null pointer, and I'm going to set the right child equal to null pointer. Okay, that's if the root is null. That makes it pretty easy. If the root is not null, it gets a little bit more complicated. We have to find where it belongs. We can either go to the right or go to the left depending on the value of the tree. The easiest way to do this, once again, is to use recursion. So I'm going to come up here and grab, anytime you use recursion, you do have to have some sort of helper method. And I'm going to call it the same name as my non-recursive version. The only difference is this one is going to have a pointer to the current node. There it is. So there's my insert. Now that I have a recursive method I can use, I can finish off my insert method by saying anything else, we're just going to insert the tree using that recursive method starting at the root. There we go. So that is it for our insert, but we do have to code now our recursive insert. It looks similar enough to our insert that I've just copied the function definition up here. I'm just going to add in the node type star current. That way I can have the pointer to my current node. That way it matches what I'm calling here. Item goes to item, and root becomes our current node. Alright, so now we got to figure out where our node belongs. We need to see if it's less than or greater than the root of the node. So I'm going to do an if statement. If the item that we're entering in is less than the cur, to start off with, the cur is the root node, but it will eventually go down deeper. If it is, if it's less than, that means I know I need to go to the left. I want to set it as my left child. Now, I do need to see if I have a left child. So if cur left is equal to null pointer, that means I can put my node right here. All I have to do is create a temp node, and then I can set the value of my temp node. So set item equal to the information I was just sent, and then I'm going to set this as the children of this temp pointer. I've got to set those equal to null. So I'm going to say temp right equals null pointer, and temp left equals null pointer. And all I've done now is created this temp node that has the information that we need. I haven't actually put it into my tree. That's what I need to now. My current left was null, so instead I'm going to change it and make it so my current left is now our temp pointer. That's not an equal sign. So now that puts it into the tree. Okay, so now we've got to go recursive. Here's why. Let me bring up a picture of my tree. So that was assuming that the left was null. What if it's not? Here, my root was null. We already had that situation where we could put in 1 there. But in this situation, suppose I wanted to add, let's do 50. I want to add a 50 node. This pointer is not null, and this pointer is not null. That means I need to go down a little further. So it's gonna run through this if statement less than. I should have done the example on the other side, I guess, but on the right side. But we need to do an else for this if statement if it's not null. And this part's pretty easy. All I have to do is insert my item to the left, and that's done. Okay, so that's if the item goes to the left. What about if the item goes to the right? So let's kind of show you. Let's put in a couple of comments in our closing brackets to show you where they go. This ends the inner if. This bracket right here ends the outer if. This bracket right here ends the insert. So we need to be right about here. We need an else for that if statement. And our if statement's going to be almost exactly the same. We need an if statement inside that's almost going to be exactly the same as this logic. So let's just copy this logic and modify it. This time, instead of saying the cur left, I'm going to say the cur right. Right? So if that is equal to a null pointer, then I'm going to create a new node, add my item in, set both the left and right pointers to null, but I do need to change this. I need to set our cur equal to the cur right. And then the other thing I need to do is my else. If my else is, if my right pointer is not null, if there is a value there, I need to go to the other direction, to the right of the tree. There we go. So this will recursively find a node value, put it in its correct spot. Alright, catch us in the next video and we will show you how to do a couple of binary tree traversals.